Hello everyone, let's learn how to find critical values from the student's t-distribution. The student's t-distribution is a continuous probability distribution which is symmetric about its mean, which is 0, and can be easily understood when we have gone through the normal probability distribution. What we see is the table of t-distribution values, whereby we have for the first column the degrees of freedom, and for the first row we are given the alpha or the significance level. One set is for the one-tailed and the second set will be for the two-tailed. To illustrate how we can go about easily in finding the critical values, let's look at the steps that we need to follow. First, we find the degrees of freedom from the first column, and then we determine the alpha or the level of significance and identify which perspective we would adopt, either a one-tailed or a two-tailed perspective. For example number 1, we are asked to find for the critical value for a t-distribution with degrees of freedom 21 and alpha at 0.01. Example 1 will be left-tailed. Example 1.1 will be two-tailed. Both tails for this two-tailed has a tail area of 0.01, and for the one-tailed it also has a 0.01 alpha on its tail. So what do? We go look for the row that is corresponding to degrees of freedom 21 and the alpha at 0.01, and that will give us a value of 2.518. When we look at the left or right-tailed, when we have this value of 2.518, on the left of the mean, we make this negative 2.5158, and on the right, we make this positive 2.518, understanding that the t-distribution is symmetric about the mean. So, as illustrated, the value on the right will be 2.518 and the values on the left will be negative 2.518. Example number 2 will require that we look for degrees of freedom 16 and alpha 0.05. Looking at the left tail, we have 0.05. On the two tails, we have the same alpha of 0.05 for both tails. And we go back to the table of values and we look for degrees of freedom 16 and alpha equal to 0.05. So 16 at 0.05 will give us a positive 1.746, and to the left of the mean, we make that as negative 1.746, and that is what we have. Positive on the right and negative on the left. For example number 3, we are required to go for degrees of freedom 27 and alpha at 0.01. We have one on the left-tailed and we have the two-tailed, both covering a tail area of 0.01. And what do? We go back to the table that we had used before, and then we look for degrees of freedom equal to 27 and at 0.01, and that gives us a value of 2.473 on the right and negative 2.473 on the left. And that is what we get for example number 3. Positive on the right and negative on the left. For example number 4, we are asked to find the critical value for the distribution at degrees of freedom 14 and alpha equal to 0.025. Okay, when we look at the one-tailed on the right and the two-tailed, we cover on the right tail 0.025, and on the right and the left tail of the two-tailed also covering an area or a significance level of 0.025 at degrees of freedom 14. And so we go back to the table, look for degrees of freedom 14, and alpha equal to 0.025, and that will give us a value of 2.145 on the right and negative 2.145 on the left, and that is the value that we get for example number 4. On the right, for the one-tailed, it's positive 2.145, and on the left, it will be negative 2.145. And the last example for this illustration is a critical value for degrees of freedom 9 and alpha at 0.005. We have one-tailed on the right and two-tailed with tails shaded for the alpha level at 0.005 with degrees of freedom 9. And we go back to our table of t-distribution values, and we see that for degrees of freedom 9 and for alpha at 0.005, the value that we get is 3.250 on the right and negative 3.250 on the left. And that is the value that is required for example number 5. On the right, it will be positive 3.250, and on the left, it will be negative 3.250. This is all for now, and I hope it has been easy to follow and that it has cleared some of the things that you needed to understand for finding the critical values from a t-distribution table of values. Next lesson will show you how it can be facilitated when we use MS Excel to find specific values for the t-distribution. Thank you for listening.